Yeah, good afternoon, my dear students. So, last class we have been discussed about uh, the wave equation. So, this is the concept we have been discussed. That means velocity of a transverse wave in a stretched string. So, but here you need to find out the wave equation for a stretched string. So, we can able to observe that how the energy which is going to be uh, transferring from one particle to the other particle in a transverse wave. So for this, let us consider that x-axis be the equilibrium position. Along the x-axis only, the wave which is going to be propagating, where the vibrations you can able to observe that along the y direction. Could you able to see that? Vibrations this direction. Particle which is going to be vibrating along the y direction. Y direction. But propagating, energy can be propagating along x
X.
direction. So that both are perpendicular to each other. 90 degrees na? Vibration as well as the propagation. So you
Yes, sir.
can imagine that this wave is a transverse wave.
Transverse wave.
Yeah. So in this, here, let us assume that this is the maximum displacement here, amplitude here. That should be considered is a at y position. So you can imagine that delta L, which is the element length here up to here. This is the delta L. Last class we have been discussed that tension is capital F. We have been considered. But according to the figure, this figure, tension is capital T. So, where horizontal component as well as the vertical components are there. So, the resultant component, if you want to calculate the tension value means when the tension is going to be takes place, when such a mass is going to be hanging to any wire, one end is fixed, other end such a mass is going to be hanging. There you can able to observe the tension here. Okay. In the, I think so you have been performed an experiment in first year. That is, what do you say? Uh, volume, uh, sorry, Meldis experiment. Did you done that Meldis experiment?
No, sir.
Meldis experiment. Now you can able to observe the well in Meldis
Yes,
experiment.
sir.
Huh?
Yes,
Chesara?
sir. Yesterday. Yes, sir.
Yeah, how the wave is going to be here, the energy can be transferring. Node and antinodes are going to be finding there. Na?
Yes, sir.
One end is fixed. That means fixed means you are attaching a string to the tuning fork. Other end,
Yes,
which is
yes,
other end,
sir.
you are hanging such a weight. When the weight is going to be changing here, weight increasing means tension is going to be increases. The number
Yes,
of nodes as well as the antinodes, which is going to be increases here. Okay, the
yes,
same thing, the same experiment. So here we are going to be calculating here the resultant component. That means at this particular position, this is a positive direction, this is a negative direction. That's why here horizontal component is x cos theta. That means f cos theta 2 minus cos theta 1. And also a resultant y component. Y component is one is in upward direction. You can observe here. This is upward direction. This is downward direction. Tension. So that f sin theta 2 minus f sin theta 1. So here the sine theta, which is the angles which are very, very small. If you consider that, there you can able to imagine that the resultant x component will be 0. X component should be 0. And where the sine theta, which is approximately equals to tan theta, then you can consider it as f sine theta 2. That means only vertical components are going to be present here. Vertical means along the y direction. The vibrations are there. We are not to be considering here x components. So that sine theta, which is approximately equals to tan, that means theta 2, tan theta 2 minus tan theta 1, which can gives you here, this is theta 2 and theta 1, not theta 1 minus theta 2. This is f delta tan theta. So f delta tan theta means opposite by here adjacent. So sine by cos, that means opposite means dy value, and adjacent means dx value. That means you can easily find out that here what is tan theta value. We are substituting f delta dy by dx. So here, which can gives the slope between the two ends of the element here. Here, in previous concept, we have been discussed that mass per unit length, which of the string, which is nothing but a delta mu, and here the length of the component. If you want to calculate here along the x direction, the mass of the element is mu into delta x, and by applying the Newton's second law, F equals to ma. So that can gives you here what is F value? This one, F delta dy by dx, by substituting all these here, mu into d square by dt square. But the thing is here, this is a general equation, wave equation. We substituting here, and you will get d square y by dx square equals to mu by f. Mu is the here mass per unit length, and f is the applied force here. That means this is the general wave equation. That means d square y by dx square equals to 1 by v square into d square y by dt square. That means the relation between the space to the time of a wave. That means in the case of electromagnetic wave is also going to be considered it as the del square psi equals to 1 by v square into dou square psi by dou t square. That is the general form equation. So we are equating all these terms, and what you will get means mu by f value, which is nothing but here v. This is the general equation, v equals to square root of f by mu. So like that, you have to derive the differential form, and as well as if you want to calculate the velocity of a transverse wave, you have to follow this, what do you say, calculation point here. This is about only transverse wave here. So what do you mean by superposition? This question is also asked as a short question in so many times. What is superposition theorem?
Superposition theorem is basically, sir, for the electrical purpose when we consider one electrical quantity idle and another the effect of the another quantity, then we will make the another quantity idle, first quantity effect, and the addition of the both effect is called the superposition.
Yes, yes, yes. But in this here, we have to say that, let you say that one wave which is going to be, this is the first wave. The displacement of the first wave is y1, and other wave is going to be moving like this. The displacement is y2. So why do you say y1 and y2? In place of y1 and y2, you can able to put it as a x1 and x2. No need to worry. So here the total displacement of two or more waves. So more waves, I am underline this, two or more waves. The total displacement of the two or more waves, which is equals to the displacement, the sum of the displacements of the individual waves. So in optics, what do you mean by optics here? Which is a branch of physics, but where we are using light and lenses.
Yes, sir.
Okay. So
Yeah.
that is optics here. So that means you can able to observe the phenomena of diffraction, interference, polarization, ever should comes under this case here. There we are, most probably we have to discuss about the interference case. Okay. So like that here, this can gives you the superposition principle here. That means what is superposition? The sum of the sorry, the total displacement of two or more waves, which is equals to the sum of the displacement of the individual waves, then you can say that that is nothing but a superposition principle. So here, which can holds when the equation governing the wave motion is linear. Okay. So here it does not hold the non-linear effects here for this case. So, but the thing is that here, what is the importance of this superposition principle here? That means which it can holds when it is holds any complicated wave motion. Any complicated wave motion. Okay. Not a transverse wave, not a longitudinal wave. So many waves are there. In the case of Fourier's theorem, there is a square wave is there, sawtooth wave is there. Okay. So many waves are there. So there we are going to be, if you want to calculate the total displacement of the waves, that means we are going to be analyzing the combination of these simple waves. So here now Fourier, he is a French mathematician. He shows that here the periodic motion, I already told you here what do you mean by periodic motion. Repeatedly when it is going to be occurred within the same interval of time, then that is called here periodic motion. So the best example is simple harmonic motion of these two, the periodic motion. So here, this can give you very useful analytical method of studying complicated periodic motions. Complicated periodic motions. Okay. That means such techniques they have been, he has been used. That technique you can known as Fourier analysis. Fourier's analysis. So that we will discuss coming class. But the thing is that what is superposition means, what is the importance of the superposition means. This is only short question. With respect to the figures also you can able to express. Next, interference of waves. What do you mean by interference? Tell me. Interference. Some two persons are going to be discussing such a point. Some other person which is going to be involving between them. Immediately other person is going to say that, yeah, we are discussing in other issue. Why you are going to be interfering with some other, like that. Okay, generally we can say. That means here, when the case of interference, if you want to express or if you want to discuss, that means it needs two or more. Is it clear? So when such a frequency or intensity of two coherent sources are going to be superimposed, that means which is going to be following the superposition theorem. So then you have to say that interference takes place. Yeah, two types of interferences there. One is the constructive interference, other one is the destructive interference. Okay. In the case of coming second year, we can discuss in optics. So constructive means the crust and trough of two waves are going to be superimposed. Then that is called constructive. In the case of constructive, you can able to observe the bright fringe. When what do you mean by destructive means? Dark. That means one wave of the crust and other wave of the trough is first wave of the crust and second wave of the trough, or second wave of the crust and first wave of the trough, which are going to be superimposed. There you can able to say that destructive interference is going to be takes place. Okay. So that destructive means dark band is going to be formed. So in interference, bright, dark fringes are going to be formed here. Okay.
Yes, sir.
But in the case of waves here, not in the case of light. So we have been discussed the light. So here, in case of waves, superimposing two or more wave trains. Wave train means, what do you mean by wave train? Continuously, the energy which can flows. okay, which can carry it out.
Yes,
So
sir.
a wave train leads interference of waves. Let us consider that for one-dimensional wave traveling along the same direction, and the waves travel with the same speed, same frequency, same amplitude, and the amplitude is going to be differing. Okay. In phase. Those are in phase, not out phase. In phase means, what do you mean by in phase?
In phase means continuous, it will go on. Its frequency is not going to change.
You can see cross, cross, trough are going to be here
Same.
matching here. Okay. So
Yes.
this is called in phase. Sir, what is out of phase means? This is out of phase.
Yeah.
Okay. Destructive. So here, these are the conditions. That means when interferences takes place, frequency should be same and the speed should be same. Those are in phase and the amplitude is also same. Okay. So that's what here you need to remember. There is a mistake is there. Y1. This is Y1. So the amplitude, the equation of two waves. So you know that y1 equals to rx equals to a cos omega t plus phi. Like that here also y1 equals to a sine kx minus omega t minus phi. And the other one is the y2 equals to a sine kx minus omega t. Two waves are there. Two are going to be, there is a difference in phase. Okay. Here kx minus omega t in phi, here kx minus omega t. Phase is different.
First wave
Amplitudes
is
are,
lagging.
yeah, amplitude is same. So here A and K are the amplitude as well as the velocity of the two waves. So that what is K? K is the wave number. That value is K equals to 2 pi by lambda. You must remember, most important objective bit. So resultant wave. So why do you say resultant wave? According to the superposition theorem, y equals to y1 plus y2. This is the superposition theorem. So by adding this, a is common in here, sine kx minus omega t minus phi plus sine kx plus kx minus omega t. Sine a plus sine b.
2 sine
2 sine a plus b by t into cos a minus b by 2. So by substituting here, 2 sine a plus b by 2 and here a sine cos a minus b by 2. By doing all this, you will get like this. There is a mistake is also there. You can check it once. So here by multiplying with the separate term here, 2a cos 5 by 2 into sine kx minus omega t into 5 by 2. So that the resultant wave corresponds to here, which is also a sinusoidal sine wave, which is representing a sine wave here, and which has the same frequency, omega, and amplitude is this one, 2a cos 5 by 2, and which is differ. How much it is going to be differed? That is 5 by 2. Next, let you consider that two cases are there. When phi equals to 0, cos phi 0 means
1.
1. Sine and also 180 degrees. So that by substituting these conditions here, how they are going to be changing. So you need to find out. That means here the condition is that the resultant amplitude, the sum of the amplitudes of these two waves, that means A1 plus A2, which is equals to here constructive. That means the maximum amplitude you can able to get when phi value is 0. So see here, I just want to show you the figures. See here, this is the resultant wave. Which one? This is the resultant wave here. And this is a y1. This is y1.
This is Y2, sir. Yes,
y,
sir.
yeah, y1 and y2.
And
This
this is the
y
resultant.
equals to y1 plus y2. Is
This
it
is the
clear?
phase difference.
How the amplitude which can be increased here, you can able to imagine. But these are in phase, crust, trough, matching. Okay, those are going to be coincide, constructive.
Yeah.
Okay. So when amplitude is slightly differing here, changing, that is also going to be observed here. So these are out of phase. Okay,
180.
out of phase. These are out of phase. అర్థమవుతుందండి?
Yes, sir.
Yeah. So this is a sign. This is a negative means cos wave.
Cos wave.
Yeah. So that both are in opposite. That's why y equals to y1 minus 2. Is there any amplitude is there?
No.
0. Okay. Destructive. This is the destructive case. This is the constructive case. Okay. Like that, with respect to the diagrams also, you can able to explain. Next, standing waves. So let us consider that one-dimensional wave. That means one-dimensional wave means the wave which can propagate only one direction. So that you can able to observe in the case of wave which can travel along a string. In Meldis experiment, you can able to observe that practically. That gets reflected from a point here. That is going to be reflecting. So this can give rise to reflected wave. So here incident as well as the reflected wave, which are going to be interfere. Okay, interfere means both are going to be here, which can follow the principle of superposition. So for this case, let us the incident wave which is going to be proceeding in the positive x direction, then the displacement of the wave which can be representing here y1 equals to a sin kx minus omega t, and other wave, a reflected wave, this is an incident wave, first equation. 7.10 is the incident wave and 7.11 is the reflected wave. That means opposite direction, the wave which is going to be reflecting back. So that that is to be considered it as a kx plus omega t. Why? Because of which is reflecting back. Okay. No need to confuse here. This is a sin kx minus omega t. This is a sin kx plus omega t. This is the incident wave. This is the reflected wave. So according to the superposition theorem, here there is no phase difference between these two waves. Okay. There is no phase difference. So what is the resultant wave here? A sin kx minus omega t plus a sin kx plus omega t. So here, what do you say here? Sin a plus sin b, and 2 sin a plus b by 2 into sin a minus b by 2. That can gives you here y equals to 2a sin kx cos omega t. So which is also going to be indicating here the particle at a particular position, which is also going to be executing a simple harmonic motion with a frequency is omega here, and where the wave, which may includes the particles are going to be vibrating with the same frequency, and also amplitude is not same for all particles. Here the amplitude which is going to be doubled here. That means it can depends upon the location of the particle here. That means location means here in which medium the wave is going to be here traveling here. Okay, so here the resultant amplitude value is 2a sine kx. When the value should be maximum here, for the kx values are 90 degrees, sine 90 is 1 here, 3 pi by 2 as well as 5 pi by 2, odd numbers, 7 pi by 2, like that. So that in this case, the amplitude of the wave should be maximum, or else you can able to say that here. See here, this is the important bit. I already told you. K is the wave number here, 2 pi by lambda. So that means here when x equals to k into x, lambda by 4, 3 lambda by 4, 5 lambda by 4. For this condition is also you can easily substitute. That means k into x. Suppose one example I am going to do here. Kx is there. Where is kx? Sin kx is there. So what is k value? 2 pi by lambda. Let us assume that x value considered as lambda by 4. Lambda get cancelled. 2 times. What is the value here? Pi by 2. What is pi by 2 of sine? Sine 5 by 2 is 1. Getting my point? Hello?
Yes, sir.
Yeah.
Yes, sir.
Yeah. Only one example. That like that here 3 pi by 3 lambda by 4. All this.
But these all values will come in the approximately sine 2 pi by 2 form only.
Yes. Okay. That means you need to know that when the resultant amplitude is maximum means 2a. When you will get these conditions, if you follow these two conditions in this equation, then only. So that the maximum amplitude means those are called antinodes. Minimum amplitude means is nodes. Are you getting where is it? One is incidenting and the wave is going to be traveling like this. Okay.
When it is touching the x axis, that is called the nodes.
Yeah. See here. Along the x direction, this is incident. And after reaching, it is coming black. Reflected wave. Getting my point? This is antinode. Maximum amplitude. Where is the node? This one.
This is the node.
No. This is also no. Okay. Minimum amplitude. There is no amplitude at all. समझ में आ रहा है?
Yes,
Hello.
sir.
Yeah.
Yes, sir.
So for minimum values, sine pi is 0. So kx value should be like this. Pi, 2 pi, 3 pi, like that. And substitute here also you will get. So these points, minimum amplitude points, you can call it as a nodes. So this is the diagram. So the distance between successive nodes or antinodes, which is nothing but a lambda by 2, half wavelength. Do you know that? The distance between successive nodes and antinodes. Successive nodes are successive antinodes. Successive nodes, the maximum amplitude, this is also maximum amplitude. A2 minus A1, which can gives you lambda. Or else, the successive distance between these is lambda by 2, half the wavelength. Okay? Definition of the wavelength. So, this is a antinode, this is node, like that. So thus, in the case of a traveling wave, all particles vibrate with the same amplitude and the particle do not attain their maximum displacement at the same time. The disturbance, okay, what do you say? Disturbance. Disturbance means somewhat you have been read out
Interference.
the introduction part of the waves. Okay, a pond is at rest. Suppose if you are going to be throwing a stone into the pond, you can able to observe that how the energy, that means you are hitting the surface of the water with a stone, how much of the energy you are going to be transferring to the water surface through the stone means that much of the energy which can flows to the all around the space. Getting my point? Water means water molecule. What are the molecules are there? H2O. Hydrogen and oxygen molecules are there. Na? You are
Yes, sir.
transferring such a energy through the stone by you only. So that the energy which is going to be spreading out. That means the pond is, there should be a disturbance is going to be takes place. That means what type of waves you can able to observe here?
That is
Hello.
exponential wave, we can say. Decaying wave.
Okay. But the nature you can observe that transverse, na?
Transverse wave. Yes, sir.
Yes. Yes. So this is about the traveling waves. But in the case of stationary or standing waves, that is also the particles, the different particles vibrate with different amplitudes, and the amplitude being determined by this position here. That means with respect to antinodes, have a maximum amplitude, nodes is a minimum. That means zero amplitude, which can attain their maximum displacements, and the wave as such as a stationary. So like that, we can able to explain. And that. Natural frequency of the oscillator, 1/2. That is n lambda by 2 equals to L, or lambda equals to 2L by L. Some equations are directly they written in the here textbook. So better to do the practice so that you can easily identify that.
These topics are broadly covered in that book, sir. Physics book, what you told, Agrawal
Yes,
book.
yes, yes. Yes.
Okay.
You can go
Yes.
for that. You can easily observe that. So if L value, length of the here, what do you say? Y, or if it is going to be increasing, the frequency value, if it is going to be changing here, lambda value, which can gives 2L, if two antinodes are there, n equals to 2, lambda value should be 1, n equals to 3, 1, 2, 3, lambda value. That means the mode of vibrations.
So that wavelength is changing.
Yeah, that means when the string which is fixed on the both ends, so there you can able to observe this. So this is the experiment, Maldi's experiment. Directly you can able to uh, see and calculate the frequency of the tuning fork value. Next, this is a short question, beats also. Okay. Sometimes along with a problematic question, this question is also asked as a essay. Okay, along with the problem. But most probably most of the time this asked as a short question. Suppose two wave trains which slightly differ with their frequencies, and which are going to be travel with the same region in the same direction, then you have to say that these are called beats. So here at a particular point, the displacement of these two waves can be represented y1 equals to a cos 2 pi f1t. Sir, why do you retain this means 2 pi omega t? Sir, why do you retain here omega in place of omega 2 pi f? Tell me. T equals to 2 pi by
lambda.
omega, or omega equals to
2 pi f
2 pi by T. This equals to 2 pi
f.
into 1 by T. Number of vibrations per second is frequency, omega. So in place of this, you can call it as a cos
Omega t.
omega. Is it clear? In place of omega, a cos 2 pi f. So there is a frequency differences are there. Okay. Is it clear now?
Yes, sir.
Yeah. But here, according to the superposition theorem also, by adding these two, cos 2 pi f1t plus cos 2 pi f2t. So cos A plus cos B. So 2 cos A plus B by t into A minus B by t. This is plus and the same mistake. Not both are minus. Okay, na? Correct it in your textbook. Formulas. Okay. 2 cos A plus B by 2 into A minus B by 2. So 2 cos here A is 2 pi f1 and B is 2 pi f2. So f1 plus f2 by 2 into t plus f1 minus f2 by 2 into t. Next. So the resultant vibration of the frequencies, which is f1 plus f1, 2 is the average frequency of these two waves, and which is differing, that is f1 double dash is nothing but f1 minus f2. Frequency is reducing, one other is the frequency is going to be increases. So that the maximum amplitude, when do you say here maximum? When the cos value should be 1, whether it is a plus or minus 1, then only you can say that there you can able to get the maximum amplitude in the case of beats. In the case of beats. So that means cos 2 pi into f1 minus f2. That means this value should be 0. That means cos 0 is 1. So when you will get the 0, that means you have to substitute the values here. So this phenomena, you can call it as a beats. So here, since each of values occurs once in cycle, and the number of beats per second in twice, which is the frequency f double dash, and the number of beats per second is f1 minus f2, which can gives you the differences of the frequencies of the waves. So you can see here, see these conditions of the waves. Okay. A slight change, slight difference is there in their frequencies. The same direction, same region only. These two waves are traveling. Is it clear or not?
Yes, sir.
Case of beats. In standing waves, incident wave is there, reflected wave is there. But whereas in the case of beats here, the same two waves are to be considered, but their frequencies are changing here. With a slight frequencies, a change in frequencies, the waves are going to be here moving in the same region and the same direction. There you can able to find out the here how the frequencies, where you will get the maximum frequency, where you will get the minimum frequency. According to that, how the amplitude is going to be varying. So you can able to see here. మీరు చూడొచ్చండి. అనిపిస్తుందా?
So at what point we can say it is a beat, sir?
Yeah, you can see here. Oh, what do you mean by beats means? See, one is starting, first wave is starting here.
Yes, sir.
Second wave is starting here. This is the first wave. This is the second.
Second.
So that same direction, same region. Okay.
Yeah.
But when these two, see here, one with another wave are going to be lagging here. At this point, they are going to be coinciding. Is it clear?
Yeah.
Yeah. That means there you can get by elaborating these, you can see here where do you get the maximum amplitude in this condition corresponding.
Okay.
Okay. Yeah, here these two are opposite to each other. This
Yeah.
is a node here. Here also, this is also node here. Are you able to understand?
Yeah. And these
Again, the
points
same two
were
waves.
coincides. These are
Same
antinodes.
here. Antinode with the maximum amplitude. Again, both are in opposite here. No. So, with respect to figure, you need to draw the figure. Compulsory.
Right, sir.
So, examples also given. Textbook, you can go for the examples. Yeah. You can see the questions here. Discuss the mode of transverse vibration of string. And first one is the velocity of transverse wave in a string. And final is the phenomena of beats. Explain beat frequency. Okay.
Right, sir.
Next is that is the vibrations of strings, and this one is in bar. Okay.
Yeah.
Now, the bar means fixed here, rigid. Okay. So here also velocity of a longitudinal wave in a bar. What do you mean by longitudinal wave? Up to this mark, we have been discussing the transverse wave.
Yes, sir.
What is longitudinal wave?
Longitudinally opposite to transverse, sir. X-axis is varying and y-axis is propagating. Means
The vibration of the particles which are parallel to the propagation of the wave, parallel, underline this, then that is called longitudinal.
longitudinal.
In the case of longitudinal wave, you may observe the compression as well as the rarefactions. CR. Transverse wave, crest and trough, no? Mode of vibration. The vibration of the particle which are perpendicular to the propagation of the wave is a transverse. Which is parallel to the wave is a longitudinal. So let us discuss about this. So out of here, expected questions is that longitudinal vibration of bar free at both ends. Okay. Clearly explained in unified physics. You can go for that. At both ends, two conditions are there. 100% expected questions. Okay. Go for that. But we will discuss this. Velocity of longitudinal wave. Let us consider that a bar of length small l and the uniform cross-sectional area is a small a. Okay. And where the Young's modulus of the material, you have to say that capital Y. And the density of the rod is rho. Okay. These are the terminologies. You have to know that what is cross-sectional area, What is Young's modulus? Okay. And also density. What do you mean by density? Mass per area, mass per volume, mass per length. So many are there. Okay.
Yes.
Related to the concepts. One is rho, one is sigma. So many. But here, according to our syllabus, you need to know the basic definition of these. Then only you can able to remember this. So this concept, you need to find out that velocity of a longitudinal wave. In previously, we have been discussed about the velocity of a transverse wave in a structured string. V equals to 1 by mu into under root T by mu. Okay, that is the equation. So in this, let you find out the displacements of all particles at any cross-sectional area, which are same in the bar, which can gives you the longitudinal vibrations. Let you find out that here, initial position at x equals, left hand side is x equals to 0, and the right hand side is x equals to L. See this? The length of the bar is x equals to 0, and here x equals to L. So what you are going to say, the bar length is L. Simply you are saying, okay, what is the length of the bar means L. How do you say? Along the x direction. The position is 0. Here the position is L. That means this is x1. This is x2. x2 minus x1
Is equal to L.
L minus 0 is L. This is the concept. This is the method you need to calculate the how, sir, how do you, sir, you have to be saying here L means like this. Okay. So here, by this, the rod length x equals to 0 to x equals to L. Let us consider that a small element on this bar is AB. That means the position is A, here the position is B. Okay. So which is at a distance, A position is at x and B is at x plus dx. So what is the length of the element here? Length of the element x plus dx minus x. Minus x plus x get cancelled, remaining is dx. So that what you say, what is the length of the element and element length antandi?
dx.
అర్థమవుతుందా?
Yes,
Right.
sir.
Yeah. So here from x equals to 0, when the rod is set into longitudinal vibrations, the planes A, B are going to be displaced into a new position, that is A to A dash as well as the B to B dash. Is it clear? A to A dash and B to
B dash.
So that the position is going to be changing here. So that means you need to say that y, the position, which can be changing into y plus dy. So, wait a minute. So that at any instant, y plus dy minus y, which can gives you y, with respect to the position here. At any instant, the displacement of the plane A to A dash. A to A dash is y and B to B dash is y plus dy. Is it clear now?
Yes, sir.
Yeah. A to A dash is y and B to B dash is y plus dy. Okay. According to the Taylor's equation. So the displacement which can gives you here y plus dy into dou y by dou x into dx. This is the equation. You need to remember that is 8.2 equation. So from 8.1 as well as 8.2, which the longitudinal extension of the element A dash B dash.
Sir,
Yeah, tell me.
This Taylor series only we have to refer this much line only. We need not to go in depth of this series, sir.
Yes, yes.
Okay.
So here, that means how the changing of the length you are going to be. That means whatever it may be, you are going to be representing means by using this Taylor series only. Okay. So dou y by dou x. The x
సార్
component, the x component, how it is going to be changing.
సార్ దీంట్లో లాంగిట్యూడినల్ ట్రాన్స్వర్స్ వేవ్ లో సక్సెసివ్ నోట్స్ లో వైబ్రేషన్ ఎలా అవుతుంది సార్
ఎక్కడమ్మా?
మెల్టీస్ ఎక్స్పెరిమెంట్ చేస్తున్నప్పుడు సార్
ఆ,
సక్సెసివ్ నోట్స్ అనేది ట్రాన్స్ఫర్స్ మోడ్ లో ఉన్న ఇంకా ట్రాన్స్ఫర్స్ లాంగిట్యూడినల్ వేవ్ లో రెండు సేమ్ ఒకేలా కనబడతాయి సార్. ఎందుకని అలా అంటే అది
లాంగిట్యూడినల్లోని
ట్రాన్స్ఫర్స్ వేవ్ లో
లాంగిట్యూడినల్లోని అంటే నీకు ట్యూనింగ్ ఫోర్క్ అనేటువంటిది వెర్టికల్ గా పెట్టుకుంటావు.
ఓకే ఓకే
ఓకే, పొజిషన్ ఆఫ్ ది ట్యూనింగ్
హారిజాంటల్
ఫోర్క్ ఈస్
ఓన్లీ
గోయింగ్ టు
ఓన్లీ
చేంజ్.
పొజిషన్ చేంజ్ అవుతుంది అంతే. మిగతా అంతా
Position of
సేమ్
the
టు సేమ్.
tuning fork, which is going to be so vibrations in this direction. Other one is ఇక్కడ ఇది
సార్ ఇది వైబ్రేషన్స్ అనేది వోల్ట్స్ మీద కూడా ఆధారపడి ఉంటాయి కదా సార్.
ఇదేమో ఈ డైరెక్షన్ లో పెడుతుంది. అర్థం. So you need to say that where the tuning fork is going to be vibrating in this direction, the string, that means the wave are going to be generating like this. అంటే ఇక్కడ నువ్వు యాంగిల్ చూసుకోవాలి, whether it is in parallel or perpendicular. If you say that this is a parallel 90 degrees, transverse. If it is parallel, there also, that means the frequency of the tuning fork is going to be changing here. Node values as well as the మనకి ఇక్కడ వచ్చేటువంటి node as well as the anti nodes values are also going to be differed with each other. Position is going to be changed. Experiment. చెప్పు, ఇంకా ఏం డౌట్ ఉంది చెప్పాలి. హలో
హలో సార్.
ఇంకా
సార్ అయితే సక్సెసివ్ అయితే రెండు సేమ్ కనబడుతుంది కదా సార్ మామూలుగా. అంటే ఇప్పుడు వోల్టేజ్ ఒకవేళ పెంచామనుకోండి సక్సెసివ్ నోట్స్ అనేది కూడా పెరుగుతాయి కదా సార్ మామూలుగా.
పెరుగుతాయి. అంటే టెన్షన్ మెయిన్ మాక్సిమం నీకు అక్కడ
సేమ్ టెన్షన్
సేమ్ టెన్షన్ కాన్స్టెంట్ పెట్టుకుంటే, ఇఫ్ యూ కీప్ ది టెన్షన్ ఈజ్ కాన్స్టెంట్, టెన్షన్ కాన్స్టెంట్ ఉంటే మనకి వేరియేషన్ కనపడుతుంది. హారిజంటల్ మోడ్ లో పెడితే ఎన్ని యాంటీ నోట్స్ వస్తున్నాయి, మా నెక్స్ట్ వెర్టికల్ మోడ్ లో పెట్టుకుంటే నీకు ఎన్ని వస్తున్నాయి అని ఉంటుంది. యూ కెన్ ఈజీలీ ఫైండ్ అవుట్.
అంటే నేను వోల్టేజ్ పెంచుతాను సార్.
ఏమ్మా?
సేమ్ వెయిట్ వోల్టేజ్ పెంచుతాను సార్.
అక్కడ నీకు వోల్టేజ్ ఏముంటుంది? నీకు వోల్టేజ్ పెంచడానికి ఏముంది?
50, 100, 150.
అది వోల్టేజ్ కాదు, వెయిట్ ఏమో. ఐ థింక్ సో.
వెయిట్ ఆ 50 గ్రామ్స్ అనే కింద మెల్డీస్ అంటారు సార్. ఇక్కడ వోల్టేజ్ కూడా మనం ఇట్లా ట్యూనింగ్ ఫోర్క్ లో అంటే దాన్ని ఏమంటారు సార్, ట్యూన్ చేస్తాను.
ట్యూనింగ్ ఫోర్క్ లో నీకు సప్లై ఇస్తున్నావు అంతే.
ట్యూన్ చేస్తున్నాను. అదే వైబ్రేషన్
డీసీ సప్లై ఇస్తున్నావు, నువ్వు దాన్ని కనెక్ట్ చేస్తున్నావు.
DC సప్లై.
Why you are giving that supply to the tuning fork means the tuning fork has to do the vibrations. అర్థమవుతుందా? సర్క్యూట్ ఉన్నది, ఆ సర్క్యూట్ లో కీ ఆన్ చేసిన వెంటనే వైబ్రేషన్ స్టార్ట్ చేస్తుంది. వైబ్రేషన్ స్టార్ట్ చేస్తుంది అంటే నేను సప్లై ఇస్తున్నావు. నువ్వు దానికి మామూలుగా అయితే వాల్యూమ్ రిజోనేటర్ కానీ లేకపోతే లాస్ ఆఫ్ ట్రాన్స్ఫర్స్, మనకి వాల్యూమ్ ఇంకొకటి ఉంది కదా మనకి, ఎక్స్పెరిమెంట్ పేరు మర్చిపోయినా. ట్యూనింగ్ ఫోర్క్ హిట్ చేస్తే రబ్బర్ హ్యామర్ తో హిట్ చేస్తే దాని మీద పెట్టి వైబ్రేషన్ చేపిస్తాం. సోనోమీటర్ ఎక్స్పెరిమెంట్. సో 3 laws వెరిఫికేషన్ ఉంటుంది కదా.
అవును సార్.
No, here in this Meldis experiment, you are not going to be hitting the tuning fork with a rubber hammer. Directly, you are connecting to the circuit lo manaki ikkada.
This is electrically driven, sir.
Yeah, electrically driving the tuning fork, and where you are 1 minute. ఇక్కడేమో మనకి ట్యూనింగ్ ఫోర్క్ ఉన్నది అనుకోండి. Here a tuning fork is there. Here, this is a string here.
Yeah.
Okay.
Yes, sir.
Here a wheel is there. Here hanging such a mass to
Mass,
this.
yes, sir.
Yes.
Getting my point?
Yes, sir.
That means in this string, if more tension when it is takes place, tension formula mg. Okay, g is constant 980 centimeter per second square or 9.81 meter per second square. When mass is going to be increases, tension is going to be increased. So that the number of modes as well as the antinode value greatly increases. Okay. Lesser is there. Mass lesser. Lesser mass. Tension is also reduces. So that node as well as the antinode value which is
Change.
reduces. అర్థమవుతుందండి?
Yes, sir.
So by using this here transverse wave equation velocity, you are going to calculate the what is the
Frequency.
tuning fork, frequency of the tuning. Okay. More frequency, maximum frequency, lesser resonance. Please remember this. Lesser frequency, more resonance. Getting my point? 512 తీసుకున్నాం అనుకోండి, resonating length value minimum 480, which is increased. Getting my point?
Yes, sir.
Frequency increases, resonating length value decrease. కాబట్టి గుర్తుపెట్టుకుని మీరు ఎక్స్పెరిమెంట్ చేయండి. ఓకే. సో దీని ఈక్వేషన్ మనము ఈ డెరివేషన్ లాస్ట్ క్లాస్లో చెప్పి అల్ట్రాసోనిక్స్ గురించి కూడా చెప్తాను మీకు కమింగ్ క్లాస్లో. ఓకే. I think so you had another class.
Yes, sir. One more class is there.
Yeah. You can go through that. Last coming week is the last class for this.
Yes, sir.
Okay. In this meanwhile, if you have any doubts regarding all this, you can send a message in our WhatsApp group. I can immediately respond.
Sir, you have shared some physics, some
Yeah.
application.
If you want to participate in that, make a group and fill it the form and submit so that they will call you.
What is actually, sir, that is?
Regarding the physics only, they are going to be conducting. They are so that innovative research ideas are there. If anybody is interested to do research in physics area, they are finding the talented people from the physics background.
Okay, sir. Right,
They are
sir.
also going to give the here prizes also. Prize money is also there. If you are interested, you can go through.
Okay, sir.
Okay.
I will try, sir. Yes, sir.
Right. All the best. Coming class 29th is the last class for us.
Yes, sir.
Right. All the best.
Thank you, sir.
Right,
Thank you,
thank you.
sir. Sarika, now you got the point?
Yes, yes.
So we should
I was
ask if there is any doubt.
विनोद जी हम कुछ चैप्टर स्किप कर सकते हैं पास होने के लिए।
पास होने के लिए अभी तक तो
हम्म,
सब पढ़ा है, बहुत अच्छा है।
हम्म।
वो सर ने बताया ना अभी लॉन्गिट्यूडनल वेव, और वो कौन सा पॉइंट एक बताया, वो 20
यूनिट
के लिए बहुत इंपॉर्टेंट सर ने बताया है।
हो गया। अभी तो वाइब्रेशन ऑफ बार्स चल रहा है ना, तो
हाँ,
लॉन्गिट्यूडनल वेव्स इन एयर, तो एयर अभी कंप्लीट हो जाएगा तो ब्लॉक 2 और ब्लॉक 4 लिफ्ट कर सकते हैं।
कर सकते हैं। एक्चुअली जो आज पढ़ाया है ना, उसके बाद ये वेलोसिटी ऑफ लॉन्गिट्यूडनल वेव इन बार, इसका हमको प्रैक्टिकल भी है। सो वी कैन अगेन गेट कॉन्सेप्ट्स क्लियर इन दिस, और इसको हमें तैयार करने से अच्छा रहेगा।
अच्छा अच्छा, हो गया।
इजीली हो जाएगा, क्योंकि 2 बार हो जाएगा, एक क्लास में भी क्लियर हो जाएगा, अभी हम लोगों ने कुछ क्लियर किया। उसके बाद अल्ट्रासोनिक्स को हमें थोड़ा अच्छे से पढ़ना होगा। अल्ट्रासोनिक्स पूरा थ्योरी है।
पूरा थियरी।
पूरा थ्योरी है अल्ट्रासोनिक्स, पीजो इलेक्ट्रिक इफेक्ट्स और वो सब।
हो गया आपका?
हाँ।
रिवीजन हो
Long,
गया?
listen, longitudinal and transverse Medley's experiment is important, and you will get a clear and clarity picture in the lab,
करेक्ट।
because exactly whatever the transfers, when the transfers, when we
हाँ
doing first method, will
हाँ
observe groups are very closer and very nearer, and exactly when we place the uh,
एंड
apparatus in
And
longitudinal
moreover, I just saw the practical book. We should see the practical book, and whatever topics are there in the practicals, that we should concentrate in theory part also, so that we will get doubly revised.
ओके।
yes,
सो
So that
practice
will be beneficial to us.
सो
very
प्रैक्टिकल
हाँ, जो
सब्जेक्ट्स और
प्रैक्टिकल में होगा उसी को हमें ज्यादा अच्छे से तैयार करना है। नया मटेरियल तैयार करने में एनर्जी वेस्ट होगा, और वो आएगा नहीं आएगा सेकेंडरी थिंग है। बट
हाँ वही।
रेडिमेड अभी हम प्रैक्टिकल कर रहे हैं, और उसी को थ्योरी में पढ़ लेंगे तो हमें कम एफर्ट लगाना पड़ेगा, हम अच्छे से सीख सकते हैं। ओनली मैथमेटिकल पोर्शन पे थोड़ा ध्यान देना होगा। वो
हाँ
कॉस
हाँ
ए प्लस बी साइन ए प्लस बी का फार्मूला, 2 cos ए 2 cos बी फार्मूला, वो इमीडिएट याद होना चाहिए, अदरवाइज हमें समझने में प्रॉब्लम हो जाता है।
वो है क्या, यूट्यूब में सर्च करें तो उसका
हाँ।
फॉर्मूला सब आ रहा है।
नहीं
एक
नहीं, फार्मूला सब आता है,
हम्म।
जब जरूरत होता है तभी नहीं आता है। फार्मूला तो सब आ जाएगा, उसको
वो
याद रखना
इक्वेशन
है।
करते वक्त डिफिकल्ट हो जाए तो।
हाँ, तो एक बार प्रैक्टिस, इसलिए सर ने बोला कि मैथमेटिक्स है, इसको हमें लिखना है, स्पेशली जितना मैथमेटिकल पोर्शन है उसको हमें लिख लेना है नोटबुक में। ओके।
लिख कर प्रैक्टिस करना बहुत
हाँ, आपका तो मैथ्स भी है तो बेस्ट है, मैथ्स का भी प्रैक्टिस करो, इसका एक साथ हो जाएगा।
बहुत बहुत
तो
एक एक वो आप बोले थे ना, वो बुक्स का
हाँ,
एक एक चैप्टर में 83 क्वेश्चंस है, मेथड्स है।
मैं बोला ना कि मैथ्स का सिलेबस बहुत लॉन्ग है।
बहुत बहुत लॉन्ग है, उसमें तो स्किप भी नहीं कर सकते। मेरा 5 मार्क्स का ही रिवीजन हुआ, देखो कैसे होगा पूरा, कुछ समझ में नहीं आ रहा है।
अच्छा, मैथ्स का ऑनलाइन क्लास नहीं हो रहा है?
हो रहा है मगर वो सर बोर्ड में नहीं लिखते ना, ऑनलाइन ऐसे सर लिख रहे ना पूरा
हाँ
चैप्टर। और अभी भी हमारा फिजिक्स और मैथ्स का कोलैब हो रहा है, दोनों एक ही बार।
हाँ, शरण्या मैडम ने कल आपने कुछ बोला था, उन्होंने रिस्पॉन्ड किया तो था, बट कुछ चेंज
किया,
नहीं हुआ अभी।
हुआ नहीं, हुआ चेंज नहीं हुआ, सेम टाइमिंग्स हुआ।
कुछ भी
तो
होगा भी नहीं, अभी एक क्लास बचा हुआ है, कुछ नहीं होगा। सॉरी बोल करके वो केस खत्म हो जाएगा।
हाँ फिर 1 डे ही 6 क्लास, कल से प्रैक्टिकल्स का है ना।
कल से कहा है?
कल से मेरा
आपका
है डेट।
आपका कल से है, मेरा फ्राइडे थर्सडे से है। ओके।
फ्राइडे कल
ओके,
जैसे मैं।
ऑल द बेस्ट, बाय।
ओह थैंक यू थैंक यू। शायद हम मिल सकते हैं फिजिक्स में।